then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Greetings, Precalculus students, and welcome to lesson number 7. Here we go. Okay, so today's lesson is dedicated to Y-Intercepts. We're not going to review anything today. We're just going to cover Y-Intercepts. This is one of our shortest and most straightforward lessons, one of the most easiest lessons to digest and get out all the nutrients. So, and apologies if this is too simple. So just want to briefly look at Y-intercepts. So say we have a Cartesian plane here. So here's a Cartesian plane, or the XY plane. This guy is X. That guy's the X-axis, that guy's the Y-axis. And I have some function going across there. And there's some function. And lo and behold, where it crosses the Y-axis is what we call the Y-intercept, of course. So there's the Y-intercept there. And to identify the Y-intercept from a graph, of course, is tremendously easy because you just look at where the graph crosses the Y-axis. However, we're going to be finding the Y-intercept not from a graph, but from the function equation. But that's going to be pretty simple as well when you understand the following fact. And here is the question to give us the following fact. So you see here at this Y-intercept, my question to you is, what's the value of X at this particular Y-intercept? What's the X value of that coordinate? And hopefully you would say 0. And if you look, any Y-intercept, so anywhere on this Y-axis, if any function crosses any part on this Y-axis, the value of X is going to be 0 because X is 0 on the Y-axis. So if I want to know a Y-intercept of a function, I just need to know the value of the function when X is 0. So in particular, to find Y-intercepts, all we have to do is plug in 0 for X. So to find Y-intercept, we just plug in 0 for X, because X is 0 whenever you hit the Y-axis. So your Y-intercept is always going to be at the value when X is 0. And this is so tremendously easy because in most cases, the easiest number to plug into a function is 0. In not all cases, but in the vast majority of cases, the easiest number to plug into a function is 0. That's why 0 is one of my favorite numbers. So we'll just look at some examples. We'll analyze how easy this is. We'll look at some somewhat tricky questions, but won't be tricky for us. So these are examples. So here is some function f of x. So let's say for the sake of argument, f of x is 13x to the 10th minus 73x to the 5th plus 12x squared minus 14x plus 53. All right, so say that's f of x, and they ask me to find the y-intercept. Well, to find the y-intercept of a function, all I'm going to do is plug in 0 for x. So basically, I'm going to find f of 0. Now, look what happens when you plug in 0 for every term that's a power or multiple of x. It just becomes 0. So this is 0 minus 0 plus 0 minus 0 plus 53. So the answer is 53. So when x is 0, y is 53. So the y-intercept as a coordinate is 0, 53. Of course, as a coordinate, the y-intercept will always be 0, something, because the x coordinate is always going to be 0. But you see how easy that was to plug in 0. You know, if I have a polynomial function, you know, everything that has x in it is going to become 0. And so, in fact, if I have a polynomial function no matter how extravagant it looks, and some people would think that this is a very extravagant looking polynomial function, the y-intercept is simply going to be the constant. Why? Because if I plug in 0 for x, every other thing is going to turn to 0. The only thing that won't turn to 0 is the constant. And you learn something similar in Algebra 1. In Algebra 1, and you guys didn't use function notation most likely for this type of problem, you had a problem like y equals 5x minus 3, and they would ask you to find a y-intercept, and you were taught this equation that y equals mx plus b, and they told you that m was the slope, and they didn't tell you wrong, and they told you that b was the y-intercept. Well, why was b the y-intercept in this equation? Because b was the constant. Because if we plugged in 0 for the x, that will become 0, and we're only left with b. So not just for linear equations or first order polynomials is the constant the y-intercept, but for all polynomials, the constant would be the y-intercept. So there's no need to look at further polynomial functions. That's too easy. It would put us all to sleep. So let's look at some rational functions really, and let's see if we're okay with those. So let's say f of x is 13x squared plus x minus 17 over 2x cubed plus 31. All right. So again, to find, and we're going to find the y-intercept, of course. That's all we're doing, find the y-intercept. To find the y-intercept, we're just going to find f of 0. So what do you get when you plug in 0 for x? Hopefully you got the same thing I got, which is negative 17 over 31. Because again, everything with an x on it's going to turn to 0. So you just left with negative 17 over 31. So the y-intercept as the coordinate, of course, is 0, comma, negative 17 over 31. Okay, still too simple. I understand. Let's take another function. Let's say h of x is 3x minus 7 over 10x cubed. 3x minus 7 over 10x cubed. So we're going to find the y-intercept, of course. I want you to try to find the y-intercept on your own before you watch me work it out. So pause the video if you need a little time to work it out. Okay, so you should have worked it out by now. So I'm very interested to see what you got for your y-intercept. Hopefully we agree. Well, I'll share what I got for my y-intercept. I got no y-intercept. Well, I got no y-intercept, but for this particular deal, h of 0 is undefined. And if h of 0 is undefined, then there's no y-intercept. So all functions don't cross the y-axis, of course. So if you have some type of graphing utensil, you can graph this function if you want. You'll notice it will never cross the y-axis. So if you plug in 0 for x and you get a value which is undefined, then you don't have a y-intercept. You know, when I plug in 0 for x, what I get is negative 7 over 0. And of course, negative 7 over 0 is undefined. So that's one you got to be a little careful about. Let's take another. Let's say p of x is 3x cubed minus x over x plus 18. Okay, so we're going to find the y-intercept. So same rules apply. I would like you to try to find it on your own first. So pause the video if you need a moment. And then when you unpause, I'll go and show you what I got. All right, so when I plugged in 0 for p, I got 0. So that means that the y-intercept as a coordinate is 0, comma 0, better known as the origin. Now, when you plug in 0 for p here, you would have 0 minus 0 on the top, well, that's 0, and 18 on the bottom, and 0 over 18 is 0. So it's perfectly fine for our numerator to be 0. The problem is for something being undefined is that our denominator cannot be 0. And believe it or not, ladies and gentlemen, that concludes this lesson on Y-intercept. So again, to find the Y-intercept of a function, all you have to do is plug in 0 for x. If you get a number, 0 comma that number is your Y-intercept as a coordinate. If you plug in 0 for x and you get something that's undefined, and then you do not have a Y-intercept. So I hope that was as easy as it normally is, and we'll see you next time.